So for today's video, I will be discussing to you about the chapter 11. It deals with switch security configuration. So first, the most important responsibility of a network professional is to secure his or her network. So most of the time, they are only concerned, or uh, most of the time most of the time think about the network, but they are not concerned when it comes to the threats or the threats actor within their networks. So now we will begin to the um about this module. So the title of the module is switch security configuration, and the objective of this is to configure switch security to mitigate LAN attacks. So, and it also has the topic title. So the implement port security, mitigate VLAN attacks, mitigate DHCP attacks, and then also this chapter 10, the switch security configuration, has the secure unused port. So the layer 2 devices are considered to be the weakest link in a company's security infrastructure. And also, layer 2 attacks are some of the easiest for hackers to deploy, but these threats can also mitigated with some common layer 2 solutions. So this is the example of what we call the secure unused ports. So it has the configuration ports. It uses the interface range command. So the fast Ethernet would be 0A to 24, and then the shutdown, and then it also changed the interface, which is the fast Ethernet 24 changed state to administratively down, and then the switch 1 config if range hashtag. So let's move on to mitigate MAC address table attacks. So this is the simplest and most effective method to prevent MAC address table overflow attacks is to enable port security. So, and also when we say this, the port security limits the number of valid MAC addresses allowed on a port, and it also allows an administrator to manually configure MAC addresses for a port, or to permit the switch to dynamically learn a limited number of MAC addresses. So here is the example. So we have the what we call our PC or the computer, and then our switch, and this is our port and MAC address and other table MAC. So here these two are our uh, threat actors or our hackers. So the PC or the switch is secured, and it has the 24 bits for simplicity. So let's move on to limit and learn MAC addresses. So to set the maximum number of MAC addresses allowed on a port, use the following command. So the command would be the switch config if hashtag switch port security maximum value. So here it shows that the maximum address is the 181.8192. So it means that S1 config hashtag interface is the fast Ethernet 01, and then it has a switch port security maximum, and then the switch can be configured to learn about MAC addresses on a secure port in one of three ways. So we have also the mitigate VLAN attacks. So when we say VLAN attacks, for the quick review, a VLAN hopping attack can be launched on one way. So this kind of attack, I have said this in the chapter 10, those attacks by um the threats actor. So we have the spoofing DTP messages from the attacking host to cause the switch to enter trunking mode. From here, the attacker can spend traffic tag with the target VLAN. And now we have the steps to mitigate VLAN hopping attacks. So the first step would be disable DTP, and then the second is disable unused ports and put them in an unused VLAN. And then the step 3, manually enable the trunk link on a trunking port by using the switch port mode trunk command. And then the last step would be the disable DTP auto trunking negotiations on trunking ports by using the switch port. And then the step 5, set the native VLAN to a VLAN other than VLAN 1 by using the switch port trunk native VLAN command. And then the example of this are the fast Ethernet ports 01, 017, and even the 01 through 024 at trunk ports. And then we have the mitigate DHCP attacks. So the goal of this distribution attack is to create a denial service of connecting clients. DHCP distribution attacks require an attack tool. So the steps to implement DHCP spoofing, it has also the steps, and then the mitigate ARP attacks, so it includes in the chapter 10, and then the DAI implementation guidelines, and then our syntax checker mitigate ARP. So these are our PC, switch, and the server, and then our port fast and BPDU guard. So recall that network attackers can manipulate the spanning tree protocol. And then we have the port fast. So when we say port fast, it immediately brings an interface configured as an access or trunk port to the forwarding state for a blocking state, bypassing listening learning states applied to all end user ports. And then when we say BPDU guard immediately error disables a port that receives a BPDU like port fast, and then the BPDU guard should only be configured or interfaces attached to devices. So we have the switch, the PC, and so the PC is connected to our switch, and then we have to configure port fast. And then when we say configure port fast, it is the bypasses the STIP listening and learning states to minimize the time that access ports must wait for the STP to converge. And also port fast can be enabled on an interface by using the spanning 3-port with interface configuration command. So that spanning 3-port fast is what we call our command. And for the alternative, port fast can be configured globally on all access ports by using the spanning 3-port fast default for the global configuration command. So in order for us to verify whether port fast is enabled globally, you can already use either the show running config begin span command or the show spanning tree summary. So when we say show running config, it will shows the what we input or enter in our packet tracer in our topology.